Hi, my name is Isaac Plunge, and today we'll be taking a nice journey into the world of relations. So, in mathematics, when we talk about relations, what do we mean? We're talking about a link or an association between two or more sets, right? It could be two sets with different number of elements in them, but then so far as there's a link between those two sets, we have a relation. So a relation is essentially a link between two sets. If I have this being representing set A and this representing set B, if set A has elements A, B, C, and D, and set B has elements 1, 2, 3, and 4, whenever there's an association or a connection between the elements of set A and the elements of set B, we have a relation. So for example, so far as it's a connection, so we can say that set A is related to set B, or set A and set B have some relation. Now there are different types of relations that we look at in mathematics. So there are basically four that we're going to consider here. Relation. Now we're just going to dive through an explanation that captures both of everything we have here. So when we talk about a one-to-one relation is a special association between these two sets A and B, such that each element of the set A maps onto or is connected to one and only one element in the set B, right? So what I mean is this element here in set A is connected to just one element in set B, right? This element in set A is also connected to just one element in set B. This element here is also connected to this, right? So if you look at it, each and every single element or member of set A has a corresponding element in set B that it relates to. So that is the definition for a one-to-one relation. We're going to come back to this and talk a little bit about it. Now the second one, or the second type, is one-to-many relation. So for a one-to-many relation, what we have is, if this is set C and this is set D, we have, for example, A, B, C, D. 1, 2, 3, 4, right? One-to-many is saying that one element of set C is linked or associated with two or more members of set D, right? So what I mean is this one element here, one element is connected to more than one element in set D. So this is one to many, right? This element here connected to this and that. This is one to many, right? So that is the one to many relation. The third type is many to many relation. So if you've been following the gist, right? We started with one to one. One to one is saying each element of set A is mapped onto one and only one member in set B. We moved on to one to many, where we're saying that each element in set C is mapped to more than two or more of the elements in set D. So it's one element to many elements, right? The third case, if you've guessed, is many to many. So a situation where we have A, B, C, D, 1, 2, 3, 4. If this is set E and this is set F, many to many relation can be defined as this element A and this element B. So many of these, right, connected to many. So this connected to that, this connected to that, many to many, right? So we have this set element C connected to both this element 2 in F and then this element 4 in F, right? And then we have multiple of these elements in E connected to the same thing, right? So it's many to many. So many of them are connected to many different elements. The last type is many to one relation. So for many to one relation, if we have set C and set D here again, right? Assuming we have elements in set C being A, B, C, and D, and elements in set D being E, F, G, and H, right? Many to one relation, if you follow the name, many elements to one element, which is a kind of relation. So many to one, right? Many to one. So many is standing for more than one element, right? Many to one, right? Many to one, right? So that is our definition for the many to one relation. So we're going to talk about one-to-one relation and many-to-one relation in great detail because they are related to a topic that we're going to discuss further. Now, if you look at one-to-one relation and many-to-one relation, what do you notice is that whatever components or whatever elements are in A, they all map onto just one element in the other set or set B, right? So here in this case, we had one come into this come into that, this come into that, this come into that. In this case, we have multiple, but they're still going on to one, right? They're still going on to one, right? So a function is a special kind of relation in which each and every member, I missed it. Okay, a function is a special kind of a relation in which the elements of the first set link up to one and only one member in the second set. So mathematically, the definition of a function is